Significant figures, significant digits, are all about maintaining the certainty of your measurements. Now, why do we care? One example that you're getting in this assignment is that you have two substances. You're trying to identify them, and they're fairly close together in their density, and that you're using the density to identify them. So if they're too close together, you might get overlap, and that might make you uncertain about which answer is correct. And so to what degree can you trust your measurements? And when I say to what degree, we mean mathematically how many decimal places out, because how many digits. That's our level of certainty. That's what I mean by certainty versus uncertainty. So we have to give these numerical values and see, is there overlap in the densities in this case? Or are we certain enough in our measurements that we should be able to use this to distinguish between whether it's hydrochloric acid or corn syrup in this case? So they're giving you a mathematical method to do that. It sounds a lot more complicated than it is. But let me back up to what I mean by certainty. If we look at our instruments, and I've mentioned some of this before, that significant figures, significant digits, and the number of digits we use, the number of decimal places, they come from the instruments themselves. So if I look at the graduated cylinder, it's marked out to the ones place. This is 10, 11, 12, 13, and so on. So if I measure in between, though, maybe my meniscus doesn't hit right on the line. If it's between these two lines, maybe I'm going to call it 10.5. Am I sure? Is everyone who's looking at it between those lines going to say 10.5? No, because it's not marked. So some people might say 10.3, 10.4, 10.6. That's fine, because when we write out that next decimal place, everyone knows that this is a digit that is uncertain. The last digit is always a guess. So if it's marked out to the 10th place, then to the ones place, then my number is going to be kind of plus or minus 0.1. Same thing if I look at the balance. The balance is digital, and so we have a tendency to want to say that it is a certain number because it's written out. Untrue. The balance is also guessing at the mass. So that last place, and especially as the balances get more sensitive, sometimes you'll see the last digit on an instrument flip back and forth, and it's frustrating every now and then. If it's close to 8 or 9, it may flip the last couple of digits. That is because that last digit is a guess even on a digital instrument, just like an analog. So in this one, it is certain out to the ones place, but the 10th place is a guess. So this would also be plus or minus 1. So if we get to this uncertainty question, it is giving you specifically the scale value is plus or minus 1. The last significant figure is considered an estimate. So what is the uncertainty? All this means is that when you make a measurement with that instrument, your answer is correct, give or take 0.1. So that's our level of uncertainty. So when it tells you to do this minimum maximum, the min-max method, where we figure out the range of uncertainty, plus or minus 0.1 is literally that. So we're going to take all our values. If we're talking about mass, then you're going to take the number of grams and subtract 0.1 from all of them. So that would give us our minimum. And then if it's talking about the maximum, then we would add 0.1 to all of our values with a 0.1 uncertainty. So if I go back to these values, same thing for volume. If it's 0.1, then I would subtract 0.1 from my values, add 0.1. So the easiest thing to do is go back, insert a column somewhere. I'm going to put mine directly to the right of mass. You could put it at the end. And I'm going to go to change column formula. You could do it by hand, but there's no point. And I'm going to go to mass. For the minimum, I want to subtract off whatever my uncertainty level is, and it says it's plus or minus 0.1. So for the minimum, I want to do minus, and it's going to give me that value for all of these. You can go in and put your title in. For my maximum, remember to specify units and all of that. For my maximum, I will go in, change column formula again, and I want to pick mass again, and I want to this time add the uncertainty. So this is the high range. I put the take on minimum. Now I'm going to give 0.1 and add that in, and it will go up that level of uncertainty. So that's what they mean by minimum and maximum. And so while I may have measured on the balance 10.1, because of the possible error of my instrument, what that 10.1 really tells me is that my measurement is somewhere in the range between 10.0 and 10.2.